YouTube now already. After streaming one time. Let's see if we are streaming. Hey, we've actually got one viewer. I wonder if we are the viewer. Okay, so let's say it's looking at, let's fix this. It's looking at target name. Do we have a name? Target type. It's looking at unit type market. There we go. So now we've got the actual type coming through. But let's look. So when we choose a random state, we actually are not, we still need to choose the best action. Choose best target. Choose best target. Where do we set? We should set moving to true somewhere. Because we set moving to false afterwards. So when we update the values, oh, we set it true here. We take a step, we set it to true also. So how about this? So for right now, no matter what we do, we are just going to choose the best action and take a step no matter what. Object is not subscriptable. Random choice. Because we can't do that. So what we can do is we can just say, let me just join into zone. See, now they can change targets, but let's change the frequency. Let's watch them be a little more. Right now they're doing something, and then they have an impulsivity of 2. So like every couple steps they deviate, like 1 in 5 ticks, they change their mind. So let's try like excuse me, 0.1. Then they should like stick to an action, and then every once in a while just change their mind. So we can see them kind of, they're not really changing their mind much. Oh, then you can see them kind of switch. So there is a problem with this. Like if we move the frames per second up, you'll see it. Especially if we do like we're gonna have to increase lifetime like 3 times as much, maybe 150. So we'll let these things run. Which that's fine. I mean, it's cool that they're doing that. I'm gonna let this play for a minute. So what the problem is right now is that they all change their mind in bulk. So we're doing that logic of every once in a while change your mind on a societal level. You can see here actually, you can see them change. Once they reach their goal, they obviously stop. But you can see them kind of like switch over, like right there. They're all broke, hungry, broke. Now all of a sudden they'll change. Oh, these groups they're horny. Oh wait, those guys decided. So we need to allow the randomness to happen on an individual basis. So we need to migrate the logic out of the um, world level and into the agent level. Potentially even the azimuth. No, the azimuth should always stay true. So the concept of this azimuth is that this is our navigation component. This is what helps these agents reach their target. Where the agent is actually the part where the logic is implemented, but also state. So the azimuth is the positional data, and the agent is the actual agent. And then in the current agency, we have a reward vector. So this is how we tell it what it wants to do, because they're not all doing the same thing. Like, this is another bug that we have. So it's not actually, they're all still going to the same target. It's not actually fully updating the target, which is another bug that we need to fix. But nevertheless, the cursor is like up, down, left, right. Like this cursor is simply where to move to. We're not actually using nowhere yet either. Nowhere should be both, should be a default or chosen state, but never a move, a consequence of some move. So we use these as results. So we have a mapping where we get a value, and we go to that index based on which position of move that an agent needs to do. That's where the logic needs to take place for this. But before we do that, I want to capture a screenshot. So our reward factor is way too high too. So let's look at where we say self reward plus. So we're doing the lifetime reward. That's why this is exploding. Let's just say that we do a tenth of that. And then we're gonna always make this an int because we do want to we don't want to go down the rabbit hole of floating point numbers. Why would I do 1? It's pretty stupid. It's still high, but it's not as explosive now, I don't think. It's still high though. Let's try another tenth of that. I can't tell. So when we get an object of here, why are we, oh, so we need to say, self target reached false, So here, this is to control our logic. We're gonna have to state why, because there's two different things that both control states simultaneously for the same thing. Like moving and target reach are not the same thing. That could be in the future potentially, but the code needs to be has the potential to be refactored. The logic needs to be consistent. So we would need to do both of these things in tandem. Change state from moving to action. That's where we would actually look at that logic for moving nowhere. Self.target reached equals false equals true. Oh, we already have target reach right here. There we go. I already have the comment too. We will factor this out for state checking. Okay. Need to trigger movement to some other state. That's right. So this is very important. This is where if the target reached is true, then we have to see, we've got it here too. Do we not have it as part of our agent? That's another way we can look at it if the target's none. So then when we go here, what we do is we say if reward equals here and not stuff target reached. This is Python, so we have to say and not invalid. Didn't I just say that? I guess not. Sometimes I gotta push save like 3 times. So now we've capped the reward. We are still getting aging rewards. Let's bump this back up to 1,000 now, because every time we did want them to reach a target, right? So let's go to this one, and then when they go to this one, they should be receiving extra thousands. Like that should be like 5,000. So choose random state. Choose random state tells us that we're like hungry. So is the action on the target? I mean, let's think. State shouldn't live on this level. State should be part of the agent. So an agent should define some state of being. An azimuth should be used for locational and directional purposes. So we could even say that the target should live on the azimuth level. Let's say home is none, because I don't like the logic of it being a set. I know we just broke everything. Markets is relevant. Let's forget about homes for a second, actually. It's funny because all we have is markets. We should be spawning homes too, even if we're not going to them. There we go. 1, 2, 3. Why is it one less? There is one less. Oh, that's still okay. There's 5 now. 1, 2, 3, 4. Do we have 4 jobs? Should be 5 jobs. One, 2, 3, 4, 5. Yeah, there's 5. Okay. Something I want to do, actually. I don't want to spawn the houses near the edge, or the works, the employers. Um, so, where's the cell size? Available cell, update grid. If cell index is available. Unit type available. Let's say reserved. And this will be 64 also. This is to delimit the map from spawning near the edge. So when we create these should be cells. I know it should be cells. I swear, if we have a grid of units, we're not. I thought it was cell. The world has a grid. The grid has agents. And agents are units. We're gonna break the whole thing. So didn't want to do cell before, but we're gonna do cell. We're gonna break it because I want to use unit instead of agent. This will make a lot more sense in like 5 seconds. Unit type. Actually, let's just replace the word cell. Unit. Unit type. Oh shit, I did that backwards. A unit should be a cell. There we go. I was wondering why it wasn't pulling up unit type. I wonder if we break it. Oh, I can't believe that works. That's insane. But now we can replace the word agent with unit. And now this makes a lot more sense. Units can die if they run out of. Okay, and then lowercase agent we can replace with the lowercase unit. Now all is good and well if it runs, and it does not run because we also need to replace agent with unit. Now this still doesn't make sense. It should make. That's it. That's it. Okay, let's do away with homes for a minute. Let's not even think about home logic because we want to implement building. Well, we do want to implement the feature of sleeping. So we'll do sleeping first. I did that. Define policies. I think I did that. choices. That's kind of implemented, but not fully. And then we want to implement sleep. With no reward. The only reward for sleep is energy. And then accept reward and except for sleep, age, and refreshing fatigue to be determined. So we're going to start with sleep and age, and then we will end with that. And then we want to remove home. We have that already, so let's move it up here. Remove home and implement building, and then we want to build a home and target. We can do that one now too. Achieve interaction with the cell. That one's not fully implemented. That one needs to be done next. Configure table for state. We've kind of done that. Right. Nova bindings. So this project will eventually run into the Vulkan graphics engine, because we're going to want to run multiple of these societies concurrently on the GPU, and have like networks of these things running. Yeah, it's going to be crazy. What's funny is people are going to probably come back later and see this and be like, damn, like right now there's no relevance to what I'm doing other than these things just moving around. But if I really can get this thing to work, and I take all of this footage and I make a proper YouTube video, like condensed to like 45 minutes, it'd be crazy. This is a huge project. I wanted to implement the edges though, so we don't want the map to spawn. So we got the world inherits the grid. When the grid initializes and it repopulates, we go through the cells, we iterate. I'm gonna make this bigger for y'all. So now the names make more sense. Now the cells are actually an array of cells on the map, and then the units are set because they're specific units. And then we have this iterator to see how many. Well, this actually gives us all of the alive ones. So I need to remember to use this. Returns all of the alive units in the grid. And then we can use this to get the length of the alive. So I need to see anywhere that we might, if we're using this somewhere else, like right here. Genome is part of the society. Self.units alive. Is there? I mean, we could do that, even though I just lost that. That's one thing I hate about having a small screen. I mean, having it blown up real big. My screen's not small. The length of units alive. I mean, that's better. It's not all the way better though. Genome. We could say define alive here as well. And we would just return self.units.alive. And that doesn't seem right, actually. I feel like I got that mixed up somewhere. Let's go back here. The grid, it gives us all the list. So all we have to do is ask the grid for the list of the alive ones, and the world can do that. So is how we do this. We put it in the grid and we say pass. And then we go into genome and we also define alive and we say pass. So now both inherited classes have this function. Neither one of them have the definition of it, but they both know it exists. So then here we can say self return self. We didn't return. Yes. For fuck's sake, I just keep pushing all the wrong buttons. Returns all of the live units in the grid. Grid.units. Indent amount. We can say self units. Excuse me. So, see, this grid actually inherits the self from here, so that's why people would call world the parent and these the children. But either way, I don't really care which way people refer to it because they both inherit traits from one another when you instantiate them that way. Especially in Python, where you can have recursive and like callback definitions. What's up, tangible? Did I say that? That's clever. It's a clever name. Be able to achieve interaction with the cell. Okay, yeah, hold on. I still got distracted. We're looking at the cell. So let's go to the settings. Let's go in here to settings, and then for the grid size, we will say that the grid buffer equals grid size. We want a tenth of that. I think a tenth should be enough. So grid size, the grid buffer will always be a tenth of the grid size. I think that's reasonable. If we need to adjust it, we can, obviously, but so we create a cell for range of the grid size square. So let's think about this. There's another way we could do this. We could iterate x and y. We create a double iterator. It's not really any more or less efficient. It is a little bit bigger in size if we think about the call stack, but the iterator size is still the same number. There's another way to do it though, because if we think about the lines, if we think about a square, if we offset it, the grid size square, like if we said minus settings dot grid buffer value squared. Now we've cut the square of the grid buffer off, and so technically it's still a square because we are decoding this based on the grid size. But then the problem there is that we have this new value we've created, which is the available grid size. So we could create another value here, and we probably won't do this, but we might. So this is why when people would say at school geometry is not useful, when will I ever use it in my life? Available buffer. I don't even know how to do this, so if this will work, it will be interesting. But the logic is this. Let me explain. Let me draw it for you guys. So if we have a square, because right now what we're doing, if this is a 10 by 10 square, then our x is 10 and our y is 10. I need a stylus. So this would be 100 squares. And if we wanted to take a tenth of 100, that would be a buffer of 10 on each side. So we want to draw an available square like this on the inside so we don't spawn anything on the outside. So if we know that we have a tenth here and we square it, that should give us 100 squares total. It's a 10 by 10 grid around the outside, right? So if we just subtract, now none of these numbers are not adding up properly. 100 by 10 by 10 squared. So my thinking's way off, actually. But the logic's right. My math is off. But if you square a tenth, you will still have a tenth of the squared of the active. Both numbers are squared, right? But we are getting a specific number. And so what will end up happening is that we have a square this size. Like if you look at this inside square, if you didn't offset it, now you have, we've basically subtracted all of this from the index. To do that though, you then have to subtract this number to get the offset here, because what we're doing is we're going through rows. Like if you look at this logic here, we are going through a row, and well, if we just look at the grid size, the reason we square it is because we're getting the whole square. Like obviously that's why we square it. And so when we get to the end of a single row, we do modulus 10. And so if we had 11 and we do modulus 10, then we start back over at 1. And then 12 is 2, 13 is 3. And then when you do 23, we'll be on that row, 33, 43, etc. So the trick to the logic is if you know this number, so much easier to program this stuff without explaining it. If you know this number, so let's look in our settings. See, we've got a grid size of 50. This is squared. So 50, 50 squared, I always think of 50 times 50. It's 250, right? And then basically we're cutting this grid in half, I think. But that's our modulus number. So the logic would be the available grid equals grid size squared times, we've already got that, right? It's not available buffer. So then to get the inside number, then we have to hold on a second. We get the grid offset equals the I think that's what it is. Yeah, we get the square root of our available grid minus, let's do grid count equals the square root twice, right? So then the available grid becomes the grid count minus the square of the grid buffer, what we did here. And then to translate this, we have to get the square root of this number, which is the size of this grid. That'll give us the x and y size. And we do that minus the grid size. Grid size minus the grid size here minus this number will give us the grid offset. So this number should be, if we say plus and minus, so if I say I want to iterate from 0 to 7, let's do 6 for simpler math, and I say I want a plus 2 from this number, that will give us this number. So if we get the grid size of 50, then we have to cut this in half at the end. So it's half of that number. So this, we can calculate all of this at compile time before we ever even build our program. We don't have to do this math ever again. So that cuts all of that out of runtime by doing it here. I know it's a bit complex in geometry, but it makes the function really easy. Because then when we iterate, we just say, for my value, I always want to be over 2 and under 2 of this number. Basically, that's what it's going to do. So it's going to say from 2 to number 8. That's what I want to iterate over. We can see if we can get this to work. I don't know if I explained that well or not, but you guys can always go back and fact check me. So we've got the grid offset on both sides. That's the starting number. We can actually say grid start here, and then we can grid end equals the grid size minus the grid start. So this would be like 2, and then this one would be 8, or in this case would be like 12 and 38, something like that. I'm just guessing. So when we iterate through these now, we want to iterate at the, let's look, we need to rename these again. God, I hate these little pop-up things over this sometimes. We can call this the grid count, because that would be our total grid count. So let's even call it total grid count. And I'm going to keep that in case we need it somewhere else. Our grid buffer, let's say grid border. Let's call it a grid border. And since we don't use it anywhere else, we're going to get an int, and then we're going to square it. We should always have an int. And then we'll just say grid border. Oh, we do have to say, do we have to say value? Yeah, we do, huh? Total grid count, value. So the available grid now becomes the grid area. Let's call this the spawn area. That is explicit. We gotta get the value here, 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 and here. And we also need to get these values. Probably not using that anywhere if it's not breaking anything. Oh, I was grabbing it by the value. I wonder if it automatically unwraps. That would be a smart feature. Grid size has no attribute value because there is no. Oh yeah, there is. Which one is that? Total grid count. Maybe none of these have that value. Ah, shit. Okay, you gotta look past this error and see what this is asking for. minds or not? Yeah, some of them are changing their minds. I thought we did iterate through these on an individual level. Maybe this is a reward, or not a reward, consequence. Yeah, it should be in an update grid. Okay, it's doing it. It's going through all of the units. If it's dead, we remove them. Thanks for the follow, by the way, Tangible. If you're still there, you're my first follower, bro. Gotta start somewhere, right? Remove iterables from unit list and prevent such steps. Yeah, select type, set it selected type. So if there's none, we select one, and then we update the target direction. So that's if what this actually does is prevents us from selecting none. I can't believe we have select target and it's not doing anything. Oh, we were going to use this as a callback somewhere, but we ended up factoring that out. Technically, we could do away with these align functions, but that's the correct way to do it, since we are calling them other places. So what's weird to me is, like, they will keep going back to this one spot. We still didn't factor in our border, though, so that's what we want to finish doing. I just think it's interesting, though, that it's running. It's not broken because of the changes we made, which I guess it wouldn't be, but... So, for the cell size, now, what we do is we go through, for I, we say settings dot spawn area dot value. That's it. We just iterate through the spawn area. But in the cell, see here we are offsetting x and y, idx. So what we want to do now is we say idx, this is the index, plus settings dot, which one is it? We better make sure we know what we're doing. Not the actual settings, not the state, not the table, not the reward, not the search, not the cursor, not the init, not the readme. Settings. We want to make sure that we start inside the grid start. So, we still do the grid size. No matter, so we don't change. Where's the damn grid at? The grid is on the meso layer. It really should be on the macro layer, though. This is our connection. The grid is grid acts as the connection between the macro and meso levels to the macro level to the meso and micro levels. So the grid really could be called a mesh. We could rename this mesh if we really wanted with it. Fuck it. Oh, it's just gonna keep going. Alright, whatever. Gotta have fun with it, man. Helper. We don't need a helper right now. I don't know if that. Are we using self in here anywhere? Oh, this is already not even. This could be in its own utility function even. Cool, we can put it right here. What better place for it? So we still need to iterate over all the cells. This should exist somewhere in a function because we call this. Do we call that more than once? I feel like we do. No. Okay. Then where did we do it before? We did it on the world level. We say where the hell did we do that at? We just changed it, like it's ugly. Where did we shit, where did we call this? I don't wanna replace it, asshole. Do we call this somewhere? Cell.set? We could call it. We could just say cell.set. That's all I gotta do. And technically, we could pull this whole populate function as a static function. Could be wrapped into a static cell function because we can populate this using this with the units in combination with the unit type. Could be all wrapped as part of the enum for unit type. That's what good refactoring looks like. The grid will still exist as a grid, but it'll exist in a logical way, which really should be combined with the world. Even some of this could be moved to the engine, so there's definitely a lot of refactoring to do. We still haven't gotten to this point because there's so much spaghetti already. We'll go through the unit type. That's when we update the grid. So when we go to the cells, we go populate. This is where we actually iterate through the population. And so how our population function works is that we have a pool where we are doing multi-threading, and we are concurrently running our units, our markets, and our home where we pass a type in, and then we pass in a number of types. So this is where we actually generate our set. So we iterate a number of types based on what we pass in for a range of numbers. So if we have 4 population, and we spawn 4 agents, and then we create a set of it from a list. I'm not going to go into why I decided to use a set, but we do add a cell. We also do check to make sure that we don't have duplicate cells. I have tested this. I can put this on verbose. That's another place we can clean up some logging. It happens very rarely. Most of the time, especially with bigger grids, we don't usually hit the same number twice. When we do, we tend to hit it like 3 or 4 times in a row, which is interesting. Yeah, so here's our grid character cells. So we just keep like going in circles here. If the cell is available. So let's look at where we pass available to a cell, because this is where we want to change some of them. Right here. When we initialize a cell type is defaulted to available. We're going to have to move this assignment down here. If the cell type is available, so we've got to figure out, it is right here. This is where we set our X and Y. So, what we do, this is the trick. Cell type equals available if self.x is, so if the settings dot grid start is less than x and x is less than grid end, and what we're going to do is we're just going to create self inbounds, self define inbounds. We're going to say for x and for y. If the y is within, so this is what I was doing on this drawing. So if we have the number 2 here, if we have the number 2 here, then if the x is above 2 and the y is above 2, and x and y are within the end of the grid, so we've already calculated all of these numbers. We've already calculated the start of the grid and the end of the grid. All we did is we shifted our grid up 1 square. And we could have calculated this 5 or 10 different ways, but that was the logic behind that. And so we let the complex math work at compile time. As soon as we run the application, we should know what our grid size is, and so we can calculate this grid start and end. And so the way our program works, we're just going to always assume it's available if we're within these bounds. So now we say self inbounds. So we set the cell type to available if we're in bounds, otherwise it's reserved. And our logic for our population already runs on that. If while the cell is not available, so we're only looking for available types. If it's available, we just skip this. While it's not available, we continue to generate new cells. So we're always looking for that available cell. Where do we check that at? Shouldn't it be up here? Populate. Oh, yeah, we just generate them at first, and then we come back, we actually don't even need this. And we could make this a pool as well. But it's okay. This is like premature optimization at this point. I don't want to ride us into a corner, and it's potential enough. It's good enough. Value start equals grid start value, end equals grid start end value. Now we can make this code even better reading anyway. So if the x and y are between the ends, then that's fine. We could even say start self x y. I think we can do this anyway. And then end. So I think we can do that. Self cells index is not subscriptable. It's a set. Why is it a set? I guess we'll say index is out of range. Why is it out of range for? Where are we getting this index? I feel like we're on the wrong grid size. I feel like we need to print something out somewhere. Let's just run it again because I can't even follow the output. Indexes, let me make it smaller too. Y'all are gonna have to bear with me because I need to see the whole thing. We set the screen size. We run it, we go to the world, we initialize the grid, we repopulate. In the populate function, we crash when we try to replace the units because the available cell index is larger than the list of cells. So when we're trying to put a unit in, is it the unit every time, or is it? Okay, so it's specifically the units here. So let's pick a number. Here's something else we can do. We are picking a number. This one's the same problem but trickier. But real quick, one thing I'm gonna do is we need to go to the world when we, is it the world or the grid? I don't like this though. We've got the grid of cells, it makes sense, but we draw the cells. If it's available, if it's in reserved or available. When we go to reserved, I want to make it a little bit lighter. Then when we draw it, we'll see it a little, we should see our border size. just set all of the markets and homes for the units to be able to know where to go. We're going to leave homes out for now. This will cause a break when we try to move to them, and we won't get a bug. Log dot log level info unit is not receiving a home. And we shouldn't actually. But we need this to test their ability to sleep. We just give them one by default initially. Eventually we want to force these things to try to build. Building won't really do anything. It'll cost money and energy, and they'll have to get to a certain level of money and energy to be able to build in the first place. So there's like this learning curve before they can unlock that. And that's the goal of this program, is to see if we can create benchmarks where first we want to see if they can learn to trade, to make money and eat, because those give rewards. Then we want to see if we can extend out the process of acquiring food to see if they will farm. And if they will farm, we want to see if they will build, and then we'll turn a farm step into a token, and we can add reserves, and we can build a society. And these things should be able to learn how to survive if we can do this right. But beyond that, we want to see if the society will learn to evolve, like generationally. So there's two different agents going on here. For those that don't know, I'll recap this real quick. But like, there's two different steps here in this whole system. We have the agent, who could be a male or female, or representing those with red and blue, and then they can trade or whatever. But something else that they can do is they can repopulate, and they can create a new cell, or a new unit, or a new agent. This process of reproducing creates an initial reward for the process, like their enjoyment. They get pleasure out of it. But also, the process of producing a child does two things. It creates a tax, so they get negative money, but they get a positive experience out of it. Eventually, we could potentially have these two things share information, but these things will inherit traits from their parents. So both of the parents will contribute some characteristics to the child, but the learning process of the system, those are agents that, like, these are the individuals that are learning to navigate energy and money. So they choose between energy and money, and also some random thing. They're also doing some random thing, and so they're going to explore the options that we put in front of them, no matter what they are. But the one constant is that they're constantly losing energy, and that it costs money to get energy. So those are the rules of the game, and we want to see if the individuals can learn. Now, what we're doing is we're putting these actions into what we're calling what we would call a Q table in normal reinforcement learning. But instead of using a Q table, we have mapped out potential action states, and then we've assumed a list of potential, like, states of beings that we would like these things to exist in, we've come up with a list of like 7, and maybe we'll extend it out and like maybe add 2 or 3 more here. But basically, we're going to use a neural network instead of a table because those tables get really, really big. And if this thing grows, we want we can maintain lookup speed with the table, which is really nice. But neural networks offer us the ability to dynamically calculate values on the fly. Like the training takes a long time, but we see improvement. The Q table, we would also see improvement, but it takes time as well. But the table, it takes a list of all of the states. So like your energy, your money, we're not doing location, but distance to a target, the type of target you're looking at, the type of action you've chosen. Like these could all be inputs in a table. And so depending on how many values there are, like if there's 7 of this one, then you need 7 rows before you get to the first value of zeros. And then you'll go to table 1, table 2, table 3, until you've gone through every possible set of actions. And you just let that thing do random things until these values over here, these measurements, or these back propagations, if you will, we do some action, we calculate some value, and then we store those values here. Then when you let this thing decide which action to do, you say, based on all of the possible actions, which one of these is the best? So that's how a Q table works. And you just continually let this thing calculate its state, and it's going to continually try to choose the best action. As much as I want to do that, I would like to calculate age. And age in a table becomes this very like linear, like every time you get to 1,000, an age, that's the first time getting there. And then maybe they only live to be 800 most of the time. So you only trained it one time to be 1,000, and so it doesn't really have experience in those areas. So you have to continually grow this thing just exponentially. It's bigger and bigger. The neural network, we're able to use back propagation, and we kind of have that, not really. I've got a couple examples where I've done it. I don't think any of these have it in it, which I'm not going to go into those right now. And I'm not really too worried about the reinforcement learning part yet. Like we're still trying to get the border on the map. We've got some of these actions. And like I said, the first thing that we want to do is we want to get energy and money figured out, and then if it's alive or dead, and then what target it's looking at. And we'll just let it choose random targets and then see if it can figure out that that eating is better than not eating. Like that's the first step. We're seeing if trade is better than not trading. So yeah, let's go back to this border. Let's get this border in place. Let's figure out how to do this. So when we go through these grids, not updating grid, when we spawn our population, somewhere in here I saw it where we are looking for I keep going back to the same functions. Available self takes the index. So when I followed the index is where I found it. It's not in the helper function, is it? So for a random int between 0 and the index size times 1 minus 1. So it shouldn't be the index size. It's not the grid size anymore. It's the spawn area, and I believe the spawn area is the whole grid size. Yeah, I believe it's the spawn area. Because the grid start and end are the spawn area, but with the offset. Like, this is just the offset. And for the record, if anyone's like into math, I'm pretty sure the only reason that we can divide this by 2 here, like, I think if we cubed these, then we would also have to divide this by 3. I'm not sure. I'm pretty sure that's correct, though. But I'm not positive. But anyway, it should be the spawn area. I don't think we need to have it be squared. I think that's all it is. But this should be settings dot grid start, because we don't want to start at 0. We want to start at like 12. And then we do it for the size. Is this the only place we do this? No, okay, that's why we've done it twice. Index start equals grid start, and then we'll do this because we need it here too. Float cannot be interpreted as an integer. I guarantee you it's spawn area. I don't know if I can do that. Is this one not an int? Should be. Still out of size. Do we say -1? No, that's not right. Okay, where is it actually breaking? This is where you say debug. Why did it not print a debug? Did it not get there? Log info. Checking if 1500 is available. Grid size. Okay, this is not accurate. It's not. We changed this. No, I didn't. Okay. Or was that just that? So easy to get lost in big programs. Actually, it's so hard not to get lost in big programs. I'm actually surprised anybody watches people write code. equal is not even our code. Why did we say grid size? There it is. So 2500, checking if 847 is available. So why are there not 2500 cells? I was just making sure my math was right. Like, so we initialize our grid. When we initialize our grid, we go through and create a blank list of cells. We can actually say cells equals cell list. That's why we don't do it there, though. Okay. I actually don't even have to declare this here, but it's fine. Units, markets, homes. We're not doing anything with homes. So this, in our populate function, we actually generate homes, and then we can place them. So we set them in this list of cells that should already exist, but it's set to grid size and not total grid count. There's the culprit. None object is not iterable. For target in targets. Now we've really done it. For targets in targets. We could just skip it, but that'll create a bug somewhere else. We need to go back to where we just were. I forgot. So here we also have to consider. So no, this should be right. So look, we could do this. We could say log info. Inbounds equals, we're going to get our boolean value, and we will say will say this is what we're gonna do. When we initialize ourselves, we're gonna say log level dot log 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 level dot info. We're gonna say we don't want to do this on every single cell. We want to do this in the grid when we create our cells. We're gonna say spawning grid with bounds. We don't have. Do we have the start? Okay. Look at that. Index start and index size. So in our cell, we will just say there we go, because I wanted to actually say that. I wanted to actually say if it's in bounds or not when we check it, when we spawn it. And I want to see which coordinates are or are not in bounds. Can you do that? Can I concatenate two strings like that? Holy shit, the print functions are taking forever, or it's looping forever. Looks like it's on a never-ending loop. I was stuck doing a duplicate. I wonder if we took it not a refactor, but like sometimes code compilers get stuck. Like that is a thing. And invalidate a cache. Okay, so I messed this up, but duplicate. There's not many of those in our code. Yep. Let's say helper, so we know the difference of where we're getting stuck. So we're getting stuck the other one. Because we are not checking if it's reserved. We're getting stuck here. Because if it is available, so available means true. So oh, I see what we did here. I see. Index start. Still getting stuck, but So we're still getting stuck here because it's not available. Can we just say, I feel like it, checking if it's available, it should still be, we shouldn't be in placing any of these in an available area. But it says it's in bounds. Okay, so 305 is in bounds, right? Where are we doing this at? Let's get back to that. In bounds, when we create the cell, grid start and grid end. So let's just spam this. That's a good way to get it. Log info, log level. We already have the X and Y position. We need let's put them both here because then that helps us in our output. And let's do one more. Log cell, creating cell. Yeah, let's see if we're actually I know it's like super verbose, but it's gonna put it all together here. Did we get past it? We did get past it. Why are we logging? Oh, put it on a new line. So it's a reiterative check here the second time. Like if we do it right the first time, it doesn't take any time at all. But you'll see here, like, that shouldn't happen. Comparing. Cannot compare cell to unit. Oh, we placed yeah, okay. Cannot compare cell to unit. So if these two are not the same, I left myself a note here saying it's not broken if it fails. Because I knew I'd forget about that. Creating new cell, what type market? So let's look. 1087. 1087 type mail. So we got a mail there. I can't compare that unit to a cell. Where do I have that at? So these things started to move, and then it found a nun type. I don't see how a target could be none. Oh, you know why? Because we took the homes away. I knew it would break. I just wanted to see where it would break. I think I even put the word break. This will cause a break. Let's see if that was it. Let's see if I'm right. Got us past that bug. Set object has no attribute alive. That's right, because units cannot be alive. What we were trying to do is define that on this level, and we have to say that's not right either. We wanted, I don't know what I'm doing right here. We just say length of self dot alive. That's why we did that. So we could just simply call the length of the alive. So we don't update statistics if we already are all dead. And we should never get here anyway. Log dot error. There we go. So here's another problem we have. When things spawn on the map, obviously we're not drawing them. It's cool watching them move, even though we can't see them moving. So when we move a cell, we need to update its index. If we're going to do this thing right, we need to update that cell in the grid. So when we update the grid, so you can't even like see. Let's do this. I think we're still actually spawning near the side. And we're having like obviously some anomalies with things flashing like that. Y'all probably can't see that, but I'm gonna have to go in a minute. See, I don't think this is right either, but it could be. I mean, if they found their target. Um, See, that looks good because it looks like it stopped. I mean, it did stop, but you can see that it looks like they reached their targets. But this is when we go back later and turn it back on verbose, and we start to figure out when when we optimize it, it should stop running when it stops running. Updating grid. See, we've got so much debugging going on right now. Like, we don't need to say every time we update the value that this unit is updating the value, or choosing a random action, or choosing a calculated action. Unit is choosing the best target, and we can turn these back on, moving to, and I'm gonna see, okay, it's taking a step towards reserved. This is actually good output. We don't want to stop them from going to reserved areas, but it looks like it's only I mean, it's cool watching this cycle like this. It would be cooler watching them change their courses of action, but and we can improve this output if we can say moving to, oh, it's like printing out the other one that's printing itself out. That's derpy. So this whole thing is the target. So when we say target direction, now this is the target, and then what is it printing after? Oh, that's the rest of the agent. Okay, let's Or is it the... Oh, okay. Now this output might make more sense. So unit, let's make this a little cleaner. Stepping reserved cell target. Let's just say target unit target. Oh, we could look unit. Check this out. We will say self.state, and then we will say target. Look at that. Let's get fancy like. So put the state at a tab, because then it'll create, it will be at an indent. Yes, I know Python, you don't like new lines without an escape. Look at her, look at her, look at her. So why's the target reserved? Oh, I wonder. Reserved. If it fails this, let's do a warning. Let's do something really cool real quick. See, there are times when GPT can be cool. Close all this. Show me how to create a Python string from a map of the following values that can be passed into a print. Map level my output to format the terminal font to a color for a given set of following log levels. Boom. And then it should give me an anti-encoding for the various logging levels. And that's all we gotta do. Sometimes GPT does save a lot of time because it would take me a while to go through and look up all those ANSI color codes and to do all that. We're not going to put it here with the log level, we're going to put it here with the logger. And we could actually map these another way or whatever, but do we want to color the font, or do we want to color the header and leave the font white? Let's just try this. Let's just try to say this doesn't even work, but this is where we'll just say log ANSI colors exit error. We will say ANSI colors level dot value, and then here we will say exit character. Cool. It doesn't color the unit though. We can take in one more parameter though. We can break all of these and say sector, and we'll pass in the sector here, and then we will color it like that. We'll break all of these, but that's fine. Yes, I know. We're just gonna go one at a time. We will say main. This is the most painful way to do this, but we'll start at the top of this one. This one is the grid, so we will say grid. And this also helps make sure that our logging is a bit more explicit about which part of the code it's coming from, so it should speed up the actual debugging process too. The next one. So this one is the cell. We will be cutting this out. So then we will copy this into all these. That one ran for a minute before it fell. I actually cannot believe that we're logging from here, so we're not going to do that at all because that's the parallel function. Cool. I like seeing colors. Engine. Yeah, we'll leave those. I kind of like those. Drawing the world, that is very verbose, but we still need to, kind of cool. Now I mean, that's actually kind of cool. Let's look at this. Unit is not. I know we still haven't even solved this damn problem. 4 unit in. Like, there's not really a reason for us to have us here. Especially when we're not doing this either, so. Man, I miss my homie Frosty, man. Unit. I could actually drop that whole object in there if I wanted to. That's pretty interesting to think about. I mean, because I am just passing a string through, really. Just passing it through on the other side of the color code. I thought I just did all of the unit ones, but I guess I'm tripping. I think this is the fastest way to do that. Maybe it just got stuck and wouldn't scroll down because it just did that to me just now. I hate the Python terminal. I mean, it's super useful when you need it, but so this is actually the azimuth, not the unit. See, this is where it can get confusing. Does this even exist anymore? No. I think that's what we were trying to get to before. We were trying to get to this point. We wanted to have the azimuth update our action. So that's the part we would like to get to. So it's saying here before it gets here. No, it is actually calculating reward. It's just negative reward. The reward needs to go the other way. That was stupid. So if this is correct, it should be the reward factor. We calculate the reward. Somewhere we'll end up at P. So the target reward should not be negative. Previous d minus the current magnitude tells us what it should be. We had it the wrong way. They still were reaching their target, but they weren't getting a reward for traveling closer. It's kind of interesting because, yeah, so if the previous distance was less, so that's the concept. It's like, you get a reward for getting closer. So like if you're at 18 and the target's at 10, if you're at 18 and you go to 17, then 17 is less than 18. So if you say where I am, or what will become my previous destination is farther away than my new destination, then you can take that difference and you can say I have a reward of 1. If you go in the opposite direction, it'd be a reward of negative 1. In this case, it's 12 and 18 and 7 and all that. But, so there might be a slight advantage towards going straight or zigzagging, which they can only zigzag. So, but once we take away that the distance for stepping, we just look at linear distance and we allow the thing to go in any direction, it should be able to figure out how to navigate in theory. If we just add magnitude should allow us to do that. In theory, we should be able to use magnitude to figure out. We could use radians. So we can just figure out which direction it's in, and we can go in that direction. As long as we both agree on what north is, essentially. Anyway, yeah, that's some complex stuff. So we're not drawing anything, and you guys probably can't see them. Let's break this thing down in simple terms. Let's go to settings. Then I'm gonna go after this. But we'll continue next time with the 10. That should be that should be all we have to do. We need to change the number of jobs to 1, the number of houses to 1, and the population to 2. Sleep values, work values, food values, sex values, and agent settings, unit defaults. There we go. That's actually kind of organized now. Screen settings. There we go. So now you can see there's like one. I don't know where they're at now. Nothing's drawing either, which is exciting, and the averages aren't working either, so we'll pick this up later. We've broke it more than we fixed it, but I think that once we actually fix it, these things should be able to exist inside of here. Like a 10 by 10, we should end up with a 1 by 1 grid. But anyway, thanks for watching, for those that have watched, and thanks for taking the time. If you are watching and are not following me, give me a follow. Shoot me a message. Appreciate you tuning in. See you guys next time.